Okay, so before we start, Math 2, number 10, we did in class, so unfortunately I'm not going to put number 10 up. I think the hints are semi-decent, so you should be fine. And then I'm only going to do number 7 and number 13. Number 13 should go pretty quickly. It's kind of hard to see what it is, though, but number 9 is the flowchart for congruent triangles, so I'm going to go over this one more time. So for the figure at the right, determine if the two triangles are congruent. If so, create a flowchart. We know they're congruent because it tells us each set of triangles is congruent, so show why or how. There's a couple of things that are actually marked on the actual picture. The first thing is you cannot solve for x until you show the triangles are congruent, or unless you know that they are congruent. Because unless you know for a fact that those two parts are equal, then you cannot solve for x. So you have to show congruency first, then the two triangles have equal parts, then you can say and solve for solve for x. So the first thing you'll notice is that you have the same markings on AD and BC. Okay, and then you also have the same markings on angle D and angle B. And unfortunately, those are the only two givens that you have. So I'm going to write down the two givens that you have. You have given, according to the markings, you're given that AD is congruent to CB. Okay, and you're also given that ADB, angle ADB, is congruent to angle ADB CBD. Okay, those are your two givens. That's it. And you want to prove that triangle, I don't know, I guess we can pick ABD, triangle actually we can go in order, ADB is congruent to triangle C, so ADB CBD. Okay, that's what we want to prove. We're given those two because those are the only two markings that come in the picture, and we want to prove the two triangles are congruent. And it actually gives us the answer. We're going to end up proving it because of side angle side congruent postulate. Okay, so let's get this set up. So we have two givens. We know that for a fact. So we're going to at least have two bubbles. First bubble, second bubble. Okay. Our first given goes in here. Second given we're going to put in here. Given AD is congruent to CB, and given angle ADB is congruent to angle CBD. Alright, we know eventually we're going to have a bubble at the bottom, and a bubble at the bottom is what we're trying to prove. We're trying to prove the two triangles are congruent. ADB is congruent to triangle CBD. And then it tells us side angle side, so I'm going to put that in. So I'm like, okay, well, then I guess it's side angle side congruent postulate. All right, so eventually we're going to need, we have a side, technically. We have an angle. We're going to need another side because we only have a side and angle, right? A side and angle, so we need a second different side to tell us side angle side postulate. So looking at here, you cannot say that AB and CD are congruent yet. Even though it looks like it, you don't know that for a fact. The only true thing that you know inside these two triangles are, or is, I should say, the I guess what I tell my class is, well, if they're kind of stuck together, which side is the same side for both that you know for a fact? And they can usually at that point tell me that BD and BD is the same side for both triangles. So we have BD is congruent to BD, the segment. BD is going to be the same as BD over here. If I pull these two triangles apart, actually I will have BD on the triangle on the left and BD on the triangle on the right. So I know for a fact those are the same. And the reason it's equal to itself is reflexive property. Okay. All right, now we have our third side. We have a side, we have an angle in between them. The angle would be the green angle that we marked first. And now we have our side angle side postulate. Okay, now that we know the two triangles are congruent, then we can say, well, since it's true that both of these triangles are congruent, that means every part that corresponds to its opposite on the other triangle has to be the same also. And we call that, one more bubble down at the bottom. Okay, that means that AB has to be congruent to CD. That means that AB has to be congruent to CD, and the reasoning is, according to your book, that congruent triangles, which is what we proved that the two triangles were congruent, gives you congruent parts. Okay, so the two congruent triangles, so that means any part that corresponds to the other part is also going to be congruent. So that means this part here, AB, is going to be congruent to CD. So if that's true, then it should be relatively easy to set up an equation to solve. So if these two parts are congruent, then that means 6x plus 6 has to be equal to 8x plus 2. I'm not going to do a flowchart for that. Right now just solve it. Solve for x, and you should get that x is equal to 2 according to the answer. All right. So that's number 9. Number 13 is a little different, very different actually. So what we have is I'm going to put a little piece of white paper on top because I don't want you guys to see what I did. Oh no. Totally see what I just did. Alright, so the way I do this is I usually color things in first, but I don't have any colors, I just had crayons. So it says, write the equation that represents the number of tiles in figure X for the tile pattern at the right. So I did, okay, so I well, here's 1, here's 2, here's 3, and then I looked at it and I'm like, okay, I can't figure out any pattern that I can figure out besides just counting the squares. So I just counted the squares. And then I said, oh, okay, well, this one's 8, that's 15, that one's 24 tiles. And then I said, oh, that's actually very close. 8 is very close to 9. 15 is very close to 16. 24 is very close to 25. So I wonder if this one's probably going to be close to 36. Okay, so kind of get where I'm going with this. It's very close to 9, 16, 25, 36. Those are all your perfect squares. So then I decided, okay, well, how is this going to work? Well, I can get 8 if I do 3 squared minus 1. And I can get 15 if I do 4 squared minus 1. And then I can get 24 if I do 5 squared minus 1. So that means this one's probably going to be 6 squared minus 1 to get me the 35. So then I decided, okay, well, that's fine, but how we got to write this up with using x, because figure x is really what I want to know. So how can I get from figure 1, the number 1, to a 3? How do I go from 2 to a 4? How do I go from 3 to a 5? So I'm like, okay, well, if I take 1 and I add 2 to it, that should give me the 3. Okay, so this is 1 plus the 2, any number 2, and then I square it, and I subtract 1, that should give me the same thing. So if I take the 1, I'm going to circle it real quick. If I take 1, right, this one right here, if I add 2 to it, then I should get 3, and then if I square it, and then subtract 1. So, let's see, what was the next one? Okay, if I take a 2, right, I'm going to plus 2. If I square it, minus 1. And then if I take a 3, plus 2, squared, and then minus 1. So all of these kind of correspond the same way. So if you take the figure number, add 2 to it, in the parentheses obviously, square it, you should get minus 1, and then you should get the total number of tiles. So if I had a figure number 4 over here, so let's say like figure 4, I would say, okay, well then 4 plus 2, which is technically my 6 up here, square it minus 1. So if I had any figure number, let's say figure number x, doesn't really matter, I would say, okay, well then figure number x would be x, whatever the number is, plus 2, square it, and then subtract a 1. So this is your final answer portion of it. Okay, sorry, I keep messing with the paper. That's my bad. Okay, so that's how I did my work. Or that's how I did it. So I was trying to go for perfect squares. Or trying to come up to perfect squares. Any other way that you come up with the same answer is fine. I just showed you guys my way. There's like 4, 5, 6 different ways to do this one. Okay, I'll see you guys in class.